Aloha and welcome. In this video, we're going to be talking about one of the more difficult sorting methods to visualize. It's called the shell sort. So I'm going to go ahead and start with the textbook, and I want to show you some of the animations that they have in here that'll help explain it. So a shell sort is essentially a sorting algorithm. It's going to take a piece of, well, it's going to take an array, and it's going to divide that array into multiple arrays, and it's going to interleave them. So the way that works is it uses something called a gap value. And a gap value is just a positive integer. It represents the distance between consecutive elements in an interleaved array. So if you had an array of X number of elements and you had a gap value of 3, the way you would find the next element in your interleaved array would be you'd take your index and then you'd add to that the gap value. So if you're currently at 1 and you had a gap value of, let's say, 3, then your next element in your sub array is going to be at 4, and then the next one would be at 7. So that's how it divides it up. So what this does, the shell sort's going to choose that gap value, what we call k, and then it's going to sort the k interleaved arrays in place. So shell sort's going to finish by performing a standard insertion sort on the entire array. So the one that we did in our previous video of insertion sort, it's going to perform that with a gap value of 1, meaning it's just a regular insertion sort. So it'll go back and do everything. The idea here is that because we've already done k number of mini insertion sorts, the final one is going to be much quicker because it's nearly sorted. So that's the theory. So let's take a look at the participation activity here. We'll go ahead and start it. So in here, they're choosing a gap value of 3. So the shell sort views the array as 3 interleaved arrays. It's going to have 56, 12, and 75. So 56, 12, and 75 as the elements of the first array. So 42, 77, and 81, or wait, no, 42, 77, and 91 are going to be the second array, and then 93, 82, and 36 are going to be the third array. So you see how they're interwoven between, with each other. So we go ahead and we click on this. So the shell sort is going to take all these and break them into their different ones, and then they're going to do sort with insertion sort on each one of those 3 different arrays that we set up. So the result is not yet a sorted array. All 3 of them will be individually sorted, but the overall is not sorted yet. So you need to pay attention to that. But granted, even though it's not fully sorted, it's still closer to sorted than the original was. So now we take these, and you can see that sorting the original array with insertion requires 17 different swaps here. So watch what happens as we go through it. So if we were to do it as one big array, it's going to take us 17 different swaps. So it's going to take this a few minutes to demonstrate that because we're going over the outer loop, and then each time we're doing the inner loop, and the inner loop is going to push these values down. So for the first one, it took 17. But now let's take a look at the modified the shell sort here. So sorting the interleaved array requires 4 swaps. So watch this. Running the insertion sort on the resulting array requires 3 more. 7 total swaps occur, which is far less than the original insertion sort. So that's why we do it. By doing something like this, using interwoven shell sort here, or a shell sort on the interwoven arrays, we're going to speed up the process of doing the sorting. So if we come down here, we've got participation activities. So shell sorts, interleaved arrays. For each question, assume an array of with 6 elements. With a gap value of 3, how many interleaved arrays will be sorted? So you need to do the math on that. With a gap value of 3, how many elements will be in each interleaved array? So do all this based on your knowledge from before. So we'll go up here and do an example. So for each, we're going to assume the array has 6 elements. Okay, with a gap value of 3, how many interleaved arrays do you have? So we're going with 3 here. So yes, the gap value specifies the number of interleaved arrays. So if we go and click on 2, do we get any more information? The number of elements per interleaved array will be 2, but more than 2 interleaved arrays will be used. Yeah, so you can try that for the different answers here. So go through these, work through it, figure it out. Then we're going to continue on here with the explanation. So with the insertion sort for interleaved arrays, if a gap value of k is chosen, creating k entirely new arrays would be computationally expensive. So we're not going to do that. That's why we want to interweave them here. So instead of creating the new arrays, we're going to sort interleaved arrays in place with a variant of the insertion sort algorithm. So the variant redefines the concept of next and previous. So instead of just going through like with an I, a counter of I going through them one by one, what we're doing here is we're saying, okay, for an element at index X, the next one is going to be X plus K, which is that gap value that we talked about. So you're not going sequentially over it. You're actually, taking an element, adding that gap to it to get the second element, and then, the, gap to get, let's say, the third if there was a third. So now we're going to be looking at the interleaved insertion sort here. So we're going to start out here. So calling insertion sort interleaved with a start index of 0 and a gap of 3 sorts the interleaved array with elements at indices 0, 3, and 6. I and j are first assigned with 3. So let's take a look at this code a little bit closer here. I'm going to zoom in on it. So we've got insertion sort interleaved. We're taking numbers, which is our array. We're taking the number size, which is the size of the array. The start index, which is where we're starting for this particular interleaved. So this function here, or this method, is being called for one of our interleaved arrays, one of our sub arrays, if you will. And then we've got the gap listed here as well. So what we're going to do is we're going to start with I equals 0, j equals 0, and temp equals 0. We're going to start an outer loop here. We're going to start it at the start index plus the gap. So we're going to start at the start index, and our start index we put in here. So for example, for 3, we'd have 0, 1, and 2. So we're starting with the gap index, and then we're going to go over the entire array. And each time we go through it, we're going to add the gap to it so that we're going from, I to I plus the gap to, further and further like that. So we're going to start out setting j equals to I, and you can see them doing this here. So when we're calling this with 9, 0, and 3, so we've got our list of numbers. 9 is the size of it. We're starting with indices with the start index of 0. We're going with the gap size of 3. Then we're going to 0, 1, 2, 3. The index of 3 is pointed to here. And then we set j equal to the same thing. So when we go and we click on next, you're going to see that it goes to this part, and it's essentially swapping those values. So 88 gets swapped with 45. So those two elements are now in order. And it explains it down here. When swapping elements 45 and 88, 45 jumps the gap and moves towards the front more quickly compared to the regular insertion sort. So it's jumping over this gap instead of going one by one. So the sort continues, putting 45, 71, and 88 in the correct order. So you can watch it going here, swapping. Then only one of the 3 interleaved arrays has been sorted by this point. So you've got to do 2 more insertion sort interleaved calls using your starting indices of 1 and 2. Everything else will be the same here. It's just your start index is going to change for that. So after you've done that, that gets you the individual sorted pieces. And to finish it off, you're going to have to do one with the indices of 1, or with a gap of 1. So yeah, calling insertion sort interleaved with a starting index of 0 and a gap of 1 is equivalent to doing just the regular insertion sort. And that's going to finish off the sorting of it. That's going to take all the 3 different pieces that we had and sort them as a whole. And it's going to be much faster because we've already done the nearly, we're going to be taking 3 nearly sorted arrays and sorting those. Or actually, it's one big nearly sorted array, and we're going to make it into a sorted array. So we go into our participation activities down here. So for each call to insertion sort interleaved numbers array X, assume that numbers array is an array of length X. Each question can be answered without knowing the contents of number array. So insertion sort interleaved of number array 10, 0, 5 is called what are the indices of the first two elements compared? So that is going to be, so if we were dealing with a gap of 5, and we look at the algorithm up here, so if we're dealing with a gap of 5, we come in here, we've got I equals 0, j equals 0. So we're starting out here. So I is going to be equal to the start index, which is 0, plus the gap, which is 5. All right, so hold on. So the question was, the indices of the first two are going to be 0, and the next time it should be 5. All right. So go through the rest of these, answering them, looking at that. But you need to look at your code up here to understand how to do that. So getting into the talking about the performance here. Uh, so uh, So shell sort, it begins with picking an arbitrary collection of gap values for each one of these, X number of, if we've got X number of gap values, X number of calls are made to the insertion sort variant function to sort, X number of, or K in this sense, interleaved arrays. So it's going to end with one more sort done with a gap value of 1, and that should finish off, the combining of all the interleaved parts into one cohesive sorted array. So it says here that shell sorting tends to perform well when you're choosing gap values in descending order. And a common option is to choose powers of 2 minus 1 in descending order. So for example, an array with 100 elements, your gap values are going to be 64 minus 1, which is 63, 32 minus 1, which is 31. So these are all powers of 2. So the gap selection technique results in shell sorts time complexity being no worse than O of n to the 3 halves. So yeah, we'll go ahead and get into here. It also mentions that it doesn't have to be in descending order or powers of 2. It says shell sort will correctly sort arrays with any positive integer gap values in any order, provided the gap of 1 is included. So we're going to look at here with the shell sort algorithm. Now we're talking about, we were doing the insertion sort interleaved up above. Now we're talking about taking shell sort and sending in gap values, sending in an array of different gap values to go through multiple sorts before we do this. So in doing this, let's go ahead and take a look. So we're going to go through this code first of all. It's going to take in right here. It's going to be called with numbers with 15 elements with 5, 3, and 1 as the gap values. So the inner loop is going to iterate over the start indices for the interleaved array. So I is initialized with the first array's starting index or 0. Second loop iteration sorts the interleaved arrays starting at an index of 1 with the same gap value of 5. So you can see it swapping out the values here. Then for the gap value of 5, the remaining interleaved arrays its start indices 2, 3, and 4 are going to be sorted. So you can watch as they go here. So after that, the next gap value of 3. So we've gone from 5 to our third one. So we're going to, the next gap value of 3 causes 3 interleaved arrays to be sorted. So few swaps are needed because the array is already partially sorted. So you can see that as we go through these, we're going to have less and less sorting that we need to do. I'm going to double speed this to make it go through here a little bit quicker. So after we've done that, then we're going to call it with the final gap value of 1 to finish off everything. So when you go through here, you notice that we have very few swaps. We've had 2, 3 swaps, 4, 5, 6, 7. 7 swaps to get to the end there. So this is a lot faster than it would have been doing it all as one big insertion sort. And then for participation activity, shell sort properly sorts an array using any collection of gap values, provided the collection contains one. So let's go back to what we learned up above. So when we're doing it, we can use whatever gap values we want, but at the end we need one with a one in order to do the entirety of it. So that's true. And so calling them with different gap sets like this, 371, produce the same result with no difference in efficiency. Uh, that's not actually correct because depending on the order of it, it will, and depending on the order of your numbers in the array, it will have different values there. So you'll need to, yeah, you'll need to take a look at that. Run it, run it on paper and see what your results are. But you're going to find out that the efficiency does change with the gap values that you choose. And then for your shell sort, you're going to have, or for the final challenge activity, you're going to have the final array is given. They give you an array like this. A gap value of 5 is used, so the array is treated as 5 interleaved arrays. So if you're doing that, what are the different ones? So you're going to have to go in here and show which ones are the sets of your interleaved arrays. And I'll leave that as an exercise for you to do. But this is our shell sort. This is one of the more difficult ones to understand, and it just takes doing it a lot. So go through here, look at the participation activities, kind of get a feel for it, run these all over again just to, help you visualize what that sorting looks like. And then, look at, the different parts of it, using the insertion sort interleaved here, understand what that's doing, and then look at the overall algorithm they have here for the shell sort if you're in order to get an understanding of this. So yeah, that's this is one of the harder algorithms to visualize. I'm glad we have something here that goes through it step by step and shows it to you. There may be some good YouTube videos out there that demonstrate this as well. But if you have any questions about it, feel free to reach out to me. Send me an email. I'd be happy to help you with it. Otherwise, I will see you in the next video. Aloha.